doctor's note. You're just saying that you're sick. Like, you need a doctor's note from you. It's been like weeks, and he refused to get tested or have a doctor's note, so they fired him. So that was the 4th time.
All right, so if this is in your graphing calculator, it says the bug is moving along the axis with a velocity. So you have to be very careful to understand that they did not give you the position function. They gave you the velocity function. Squared, sine, make sure you are in radians, t cubed minus 1.5t. What? Did you graph it?
I'm getting an EKG when I graph this.
Oh, yeah, when I
All right, so it says find A of 0.7. It's on the bottom of the one page. Like, it printed funky. It's on the bottom of the page before it. You have the problem. There's that. Now, if you flip it, the problem... Nope. Maybe you stapled it backwards. Yeah. He's like missing it.
I'm glad we didn't have to find the derivative of this.
2, 3, 4, 7, 8. There's no 6.
No, it's just funny because it's graphing so crazy, and then you get the little 0 to 2, and it's just kind of normal.
Alright. I don't know, please.
Am I crazy?
Yes, but I might have another blank one for you.
No, I'm saying
That's what it is. Alright. So when you do this on the calculator, what you want to do is go to second trace again. And go down to option 6. And then type in exactly 0.7. Ew. I'm going to turn this off. You did it on the home screen? Yeah, because if right now the way my window is, it's like negative 10 to 100. So like I would want to be at like negative 1 to 1. Yeah, but I can be small. Maybe better not be there. This is the reason you're allowed 2 graphing calculators on the AP test. Because while this is functioning, you could like be doing something else on a different problem. Because they are very well aware that these new calculators are a lot slower. So do we get negative 0.9205?
So how do I get to dy dx of the function? What do I go to?
Second trace, option 6, I believe. Yeah. All right. So it says find A of 0.7. So A of 0.7 is that negative, I just took mine off my screen. Negative 0.9205. And then it says, is the bug speeding up or slowing down? Well, the only way to answer that is to also know V of 0.7. So my A value is negative, and my V value is also negative. So a negative V and a negative A means that the bug is speeding up. So the bug is speeding up because A of 0.7 is negative and V of 0.7 is negative. Are we okay with that? Part B, find any values of t in the interval 1 to 2 when the bug is at rest. So now if I only want to look at the interval from 1 to 2, what I'm doing on my calculator is limiting my from 1 to 2. So when is the particle at rest? When velocity is
0.
Good. So my y equals is the velocity graph. So what I want to do is change my window so that my x min is 1 and my x max is 2. And all I need to do is look to see if it crosses or touches exactly the x-axis.
And he does.
Yeah.
Twice. There is no 0, 0. That's what we're between 1 and 2.
Yeah. So be careful of that, because that's what they want you to make the mistake of. So I zoomed in on my screen, so I only see 1 to 2 on my window. Because like she said, there are other points. So then it says, find any values of t in the interval when the bug is at rest. So to get those values, you do second trace. And then you go to number 2, which is 0.
We have to do it twice.
Yep, and you got to do it twice. So you got to go to the left and to the right. Yes, so 1.225 or 1.2247. I always tell you to go 4. The rule is you have to have 3 on the AP exam. 4 is safe. So 1.2247, and then the other one is at 1.8011.
Can we not round that last digit?
No, just truncate it.
Well, then if I didn't round, I would have been right on homework last night that I rounded. So that's why I was wrong.
And should work. That's what I said. And should work.
Again,
All right.
I'm not disputing with you. I just think that's
I know.
stupid.
I've just tried to save you.
I know, but I think AP's stupid for that.
So,
So wait, I'm sorry, there's 2 answers.
correct.
Well, does
the bug change direction at both of these times?
Yes.
Yes. Because the bug from 0 to 1.2247 is moving backwards.
To forwards.
And then it's moving forwards from 1.2247 to 1.8001. And then it moves backwards again. And we don't know when it changes to forwards again. More than likely it does. But just getting into the understanding of forward, backwards, forward, backwards. Okay? Part C, find the open intervals on 0 to 2. So they specify open intervals. They've now also changed the range to be 0 to 2. So I'm going back to my x-min, changing it to 0. Now it in graph. And it says find the open intervals when the bug is moving to the right. Moving to the right is the same as saying moving forward, or the same as understanding when the velocity is positive. So in the case of this, did extending my graph to the left of 1 matter?
No.
No, because it's all negative. So the answer is 1.2247 to 1.8011. Yep. And they're an open interval or open parentheses because at those 2 points, the particle is at rest. Part D, find the acceleration of the bug when v of t equals -1.
2A.
So what I would do personally is find the intersection of -1 and my velocity graph. So I'm going to my y equals, and I'm typing -1 into y2. Because I need to know when the velocity is -1. So the easiest way to do that is to find the intersection of the velocity graph and the line -1. And we can see that it intersects right over here. So now what I'm going to do is hit second, trace, go to option 5, which is intersect. Honestly, like, I'm going to move them to this, but you could literally just leave them anywhere in the screen. And because there's only one point of intersection, it's going to find it. So they intersect at 1.8368 seconds. So here's where we are.
Now we're gonna have to put that in
Correct. So now, what I would do is take, that answer is now stored in my calculator in X. So watch, this is kind of cool, right? So if I hit second quit, and I go to my home screen, and I hit the X key, and just hit enter, the answer to the point of intersection is stored in my X value. Does that make sense? So now you could hit math 8 ddx, your vars, y vars, function 1, and then you have two choices. Here you could go up and highlight that answer, and it will fill it in, or you could have actually just typed the variable x, and it would fill it in because we already stored x as that intersection point. Did everybody see that? So the acceleration of the bug when the velocity is -1 is negative 28.873 units, whatever, squared.
My husband's like, I have a meeting at 10, and that's when the mass is. And I was like, well, he has a ride home if we can just get him to the church. So much stress.
All right. Good? Monday. They already, like he said, when did they go back to school? But like I sent my kid to school, down to periods 1 and 2. He left for, he missed Spanish, he'll miss honors chem and study hall and lunch. And then he'll go back to school for the rest of his day. So he went for like AP computer science and honors global. But like I'm not worried about Spanish 1. All right. Let's look at the next problem, which I re-photocopied you guys the next pages because they were kind of funky. So this is just like a bunch of glitchy. All right, so now we have a table, and I know how much you guys love tables.
Why? It's glitching out on me.
So here's nice new clean pages. So it says for 0 to t to 8 seconds, a particle moves along the x-axis and the position I'm going to write on these by hand because this is being so goofy. Velocity and acceleration of the particle are considered to be differentiable. So if something is differentiable, it is also continuous. And modeled by these equations here, selected values are shown in the table above, where t is measured, x of t is measured in meters. So there you go, Alex. We got a meters in a second problem. Is the particle P moving towards or away from the origin? Is it moving towards or away from the origin at t equals 4 seconds? Give a reason for your answer. So what we have to do in order to determine this is consider where is the particle at 4 seconds?
6.
Perfect. So x of 4 is equal to 6. Then we need to determine what direction the particle is traveling at 4 seconds. Perfect. So you're going to look at v of 4, which is -1. So it means the particle is moving left toward the origin. So is the particle moving towards or away from the origin at t equals 4? Well, we've shown its position and its direction. Give a reason for your answer. So we can say that the particle is moving towards the origin at t equals 4 because the particle is 6 meters to the right of the origin and moving left. Is the particle speeding up or slowing down at time 7? Okay, so she says speeding up. Give a reason for that answer. Okay. So I would say the particle is speeding up at t equals 7 seconds because, and I would show that v of 7 is equal to -4 and a of 7 is equal to -3.
Should I just say because velocity and acceleration share a negative sign?
You're always better to show the value from the table. Oh, yeah, then as long as it's off to the side.
Yeah.
Like how here I had it off to the side.
Yeah.
Yes. I just didn't read it off to the side. So it says particle speeding up at 7 seconds because v of 7 is -4 and a of 7 is -3. And both are negative, or you could say have the same sign. Yeah, so you could say and both are negative or both have the same sign. Either one is fine. Part C, use the data in the table to approximate v of 2. So this is where you would use the slope of the secant because it has the word approximate. Or if it has the word average. If it asks you for the actual derivative, then you need the actual derivative if it's possible. In this case, it's not possible because we don't have a function, we only have a table. So we would find VP of 2 exactly. So you're going to use x of 3 minus x of 1 to approximate the velocity at 2. So you use position to approximate velocity. And it said indicate your units of measure. So again, position is meters over change in time. So your units are meters per second. Is there a time C where on the interval 1 to 7, the velocity is equal to 0? So that means that we need velocity to do what?
Cross the x-axis.
Yeah, and how could you show that velocity crosses the x-axis?
3 and 4. This sign goes from positive to negative.
It's IVT, and exactly the interval is 3 to 4. But the guarantee is IVT.
We could also use 1 to 7 at that point, or 3 to 7.
Exactly, because all you need is a change in sign. So, yes, by IVT. Yeah, I wish.
No. Because you have to state from 3 to 4.
It says, yeah, it says like, is there a time in the open interval? So we would say yes by IVT. Yep.
Did you say differentiable too?
Yep. Because it differentiability
By
applies,
saying
you have to say that differentiability applies continuity.
By saying IVT, we already are saying we understand that and that IVT applies.
You still have to say it. Because it doesn't say it's continuous up here. It says it's differentiable. So you need to use the idea of differentiability implies continuity, and that's why IVT works.
Well, if I know IVT works, clearly I know that.
So yes, by IVT, the interval 3 to 4 of V of PT will give a time at which V of PT equals 0 because V of PT is differentiable and continuous from 1 to 7. And for safety, I would show what V of 3 is and what V of 4 is to show that there's a sign change. So I would say, since V of 3 is greater than 0 and V of 4 is less than 0, in 3 to 4, V of P will equal 0.
I put 0 is guaranteed to occur in that domain.
That's fine. On the closed interval 5 to 8, a second particle moves along the x-axis. The position of the particle is modeled by the given equation. At time t equals 7, our particles P and Q moving toward or away from each other. So if we need to know if they're moving toward or away from each other, we need to know their position at time 7. So x of q of 7
I think we should do this one over and repeat.
So position of Q at 7 is 3. Position of P at 7 is 5. And then we need to know the velocity of Q and P at 7. So the velocity of P at 7 is -4. Which means exactly it's going to the left. And then the velocity of Q at 7, well, now I need the derivative of that. So x q prime of t, 12 is 0. So you get -2, 10 minus 10, t minus 10 times 1. We get -2, 7 minus 10. So 7 minus 10 is -3. -3 times -2 is +6, which means that Q is moving to the right. Exactly. So are the particles moving toward or away? They are moving toward each other. It says explain your reasoning. So we would say particles P and Q are moving toward each other because Q is at 3 meters and moving right, and P is at 5 meters moving left.
Because it's in our work, you can see that it's moving right because if you don't have to say
Exactly. All of like the justifications is in this. So showing, that's why like you have to be so careful about how you like label it. Like this drawing up here meant nothing. What mattered was x of q7, v of q7, x of p7, and v of p7. That drawing is more for me to like see it myself and for you to see what I was getting at. I do.
I have one on my toes now.
That doesn't help her. All right. I was debating if I just want to tell you to finish these.
Oh, that's a lot.
It's 4 questions.
That's a long 4 questions. No,
All right.
3.
Well, we're not going to do the table. Oh, yeah.
That's 5 questions. Parts A through
Well,
F.
let's finish 3. All right. So let's fill out this chart real quick. If the bug is stopped, that tells us what?
Velocity is 0.
Perfect. If the bug is moving to the right, that tells me.
Velocity is positive.
If the bug is moving to the left.
Velocity is negative.
If the bug turns around.
Velocity changes sign
Perfect.
and equals 0. Well,
That's implied. Yep. If the bug is speeding up.
velocity and acceleration have the same sign.
And if the bug is slowing down.
They're opposite signs.
We're going to skip example 3. And then I'll.
I don't. I hate them.
That was just more obnoxious than anything else. Like, you just put it into your calculator and then, like, type in 1, 2, 3. Yeah, it's just, like, obnoxious. Like, at this point, I know you. And then you have to do it for velocity and acceleration. So you were just plugging. Yeah. The only thing I would want to show you is if you wanted to find. Exactly. Like, how do you find the second derivative? So what I would do is, and I'll just kind of walk you through it quickly, but without finding all of the points. In y1, you would type your original function. So it'd be like sine of e to the 0.5x. And then what I would do is in y2, hit math 8, type x vars, y vars function y1.
And then go math 8 bars y2.
Exactly. And then for acceleration, you do it again, math 8, x, and then instead of y1, we're going to put in y2. Yes, so x is equal to x. So what that does is that finds the derivative at all values of x. And then if you wanted to get your answers, or the 1, 2, 3, 4, 5, you would go to the table.
Can you hit graph, please? I just want to see.
Oh, it's going to be a mess, but yes. Zoom. They're really small numbers, so let's do window. We'll go 0, because this asks for 5. And then it is. So it's going to be like, I'm going -1 to like 18, because I know that that's a good scale. So the first graph in blue is my position. So like looking at that right now, I already see that this has an extrema, extrema, extrema. That's where I'm going to have my zeros. Yep.
That's a point of inflection.
Because it's an extrema velocity. Yep. Why did I not take into account that this goes way further down than it does? So acceleration is going to be the slowest to graph because it's taking like the first equation to the second equation to take the derivative again. Oh, I'm an idiot. It goes to a -11 on acceleration.
Are you just random? Oh, sorry.
Okay, it'll graph faster this time because I already did it. So finish those next 3 examples for homework. So example 4, 5.
You have 4 examples.
Oh, man.
So we can only do 3? Just this page for homework? I agree. Thank you, subscribe.
Cal. They were in that Cal shirt every day.
Franciscan.
Well, technically, like they're all
Doesn't
AP
count
questions,
that.
so they should take you about 10 to 15
We're
minutes.
doing all of
No,
Literally,
we're
that
we're
almost
not-
passed
we're
out.
not
She
doing
came
number
into my
seven. Number
work,
seven's
the
for bonus.
Franciscan, like, Tennessee was eating
Yeah.
dinner.
Well, he needs it because he didn't do one of his pages for homework today.
Dude, Blaze didn't.
Yeah.
I didn't know we were gonna do it.
It was 2 multiple choice. Like, he could have circled it on me this morning.
Oh.
I know, but I also looked for your work.
No, you need to get bonus. I should have got bonus. I did 3 and 4.
Yeah, she did do
And I was
3 or 4.
absent.
You only.
But
you
I
only did
also,
3 and 4 because you were absent.
I also made sure you had everything. Because I could have, like, you know what I mean? Like, I went out of my way to make sure it was a PDF and I sent it to you because I knew you'd do it on your iPad. So I had to, like, take my documents and turn them to PDFs for you. I always say that. I was like, I hope they know, like, we put in a lot of effort, too. Like,
You don't have to do that if you don't want to, though, because if I take screenshots of it, it can turn into a PDF, too.
but you still have to get them.
But then you have to take screenshots.
And I can't carry.
Oh, yeah. No, I mean, if you
Like,
sent
if I
it as
sent a
if you
picture.
sent that as a Word document, I could screenshot the Word and it would save as a PDF.
The problem is sometimes the Word documents get
Yeah,
goofed up.
crazy.
Like, that's what happened
Whoa.
with them. Like, ow. So, there's your drafts.
Can I just look?
I need